This is the first lesson of Unit 2, Solving Equations and Inequalities. In Unit 1, you learned how to identify and solve 1- and 2-step linear equations. In this unit, you will learn how to solve any multi-step linear equations or inequalities in real-world applications or word problems. So in what I just said, is there anything that sounds unfamiliar to you? How about the word linear? What is a linear equation? Go ahead and write this down. A linear equation is an equation that does not have any exponents larger than 1. If you have an exponent larger than 1, then you have to write it. So look at our examples down below. Which one of these is not an example of a linear equation? Problem number 1. Do you see any exponents that are greater than 1? No, I see a variable of x, but it doesn't have any exponents on it. Look at problem number 2. Do you see the exponent of 2 up in the air? Because that has an exponent of 2, this is not considered a linear equation. The other two examples there, problem number 3 and problem number 4, do not have any exponents greater than 1, so those are all linear equations. In this lesson, you're going to learn about the 6 steps to solve any linear equation. If the equation is not linear, you will not use these steps. And that will be in your next course of Algebra 1B. So 6 steps to solve in any linear equation. These 6 steps you're going to use throughout the rest of this course. And I have a quick mnemonic to help you remember the 6 steps. Do you see the little person holding the compact disc? It's a CD, right? So here's a way to remember the 6 steps to solving linear equations. Say out loud, CDICIC. It's kind of like a pun on words there. Instead of the word EYE for I, it's just the capital I. CDICIC. CDICIC stands for cross-multiply complex fractions. We just did that in the do now. Distribute if you see parentheses. So in this lesson, you're going to learn how to solve equations that have parentheses in them. And if you see parentheses, yes, we're going to apply that distributive property you learned in Unit 1. Identify the variables in constant terms. What does that mean? Circles and squares. Put our training wheels on. Then combine your like terms. Remember, change the sign. If you cross the line, change the sign, and then you use SOB. Isolate your variable from the coefficient. Remember, under, up, and multiply, beside it, divide it. And finally, what's our last step in any solving an equation problem? Check. So I would write down, you have a place, I believe, on your paper to go ahead and write down those 6 steps. Cross-multiply complex fractions, distribute if you have parentheses, identify the variable in constant terms, combine your like terms, isolate the variable, and check. Go ahead and push pause if you need more time to write those down, but do write those down, and do take some time memorizing those 6 steps in order. You're going to use those 6 steps throughout the rest of the course. And knowing the CDICIC is just a quick mnemonic to help you remember those 6 steps. Okay, so as we begin lesson 2.1, equations with distribution, our main objective for this, besides the other objectives of you need to know those 6 steps to solving any equation, is that you can solve a linear equation that requires the use of the distributive property to remove parentheses. Remember our definition of what it means to simplify, to undo parentheses with distribution. Use that double rainbow. And then combine your like terms with SOB. So let's just review again the distributive property. Here we have some expressions, right? No equal sign there, so all we can do is simplify. Let's go ahead and simplify these problems right here for review. When you see parentheses, you take the number that's directly beside your parentheses and you're multiplying it to every term inside the parentheses. There's that double rainbow. So you would first multiply 6 times positive 5p. So a positive times a positive is a positive 30p. Do we need to write the plus sign in front of that, or the positive sign in front of the 30? No, we do not, because it's the first term in our answer. So then we multiply 6 times what? Positive 4. Don't forget that sign there. So it equals 6 times 4 is 24, but we need to remember to do what? Write the sign. We have to write positive 24. Don't just write 24 down. And when you simplify, make sure that your final answer is in standard form. Do we have it in standard form right now? Yeah. Our variable term comes first and then our constant. So good. We're in standard form. Let's do the second example there. Multiply your number on the outside of the parenthesis to every term on the inside. So we have positive 4 times positive 1. That equals positive 4. Positive 4 times negative 7n. A positive times a negative equals a. Remember, when you multiply or use your distribute property, that's when you can use your sine triangle or your any of the other mnemonic devices, the happy, sad face, whichever one you use. So we have a positive times a negative, just cover it up, equals a negative. Negative 4 times 7 is 28n. So 4 is a constant, 28 is a, or negative 28n is a variable term. Oh, we don't have it in standard form, so let's rewrite it. Our final answer should be 28n plus 4. And we had to write the positive sign on that 4 because it was no longer the first term in our expression. Let's do the next one. Negative 4 times negative 6. Negative times a negative is a positive. 4 times 6 is 24. Now do not do this and then say negative 4 times negative x. Don't do that. Wait until after you've multiplied before you decide which sign to write. So we have a negative 4 times a what? Not an x, a negative x. So a negative 4 times a negative x equals a, well, a negative times a negative is a positive. That's why I say don't write that negative sign right away. Wait until after you've multiplied. Negative times a negative is a positive. 4 times 1 is 4. And then you have your x. So we have a constant term and a variable term. Oh, we need to turn it around and write it in standard form. 4x plus 24. Don't forget the sign there. That 24 we put in the back and it was positive, so we need to write the sign because it's no longer the leading term. We don't have to write the positive sign in front of the 4x because we put it in front. Alright, last example. Let's see, can you do this on your own? Go ahead and do it and then push play when you're ready to check. Ready? Negative 4 times x equals negative 4x. Negative 4 times positive 2 is a negative 8. Here you have a variable term and a constant, so it's in standard form. We're done. The final answer is negative 4x minus 8. So that was what it meant to simplify when we have parentheses. Now we're going to be looking at equations that we're wanting to solve that have parentheses. So now we're solving, not simplifying. Now you do have to simplify the side. So do we have any complex fractions in this problem? No. So we get to skip step 1. We're done with that step. Step 2, distribute. For C, D, I, C, I, C, yeah, we're ready to distribute. Now we need to look at our parentheses. multiply the term on the outside of the parentheses to each term on the inside. Now that doesn't mean don't do the 80. You're not multiplying the 80 to those because that 80 is not directly beside your parentheses. Only the -2 is. So I'll just start copying down the problem. 80 is equal to, and as I work from left to right and then I see, oh, I need to distribute, I'll go ahead and do my multiplication now. -2 times positive 4x is negative 8x. Then multiply the -2 times the -8. Yeah, don't forget the sign there in front. A negative times a negative is a positive. 2 times 8 is 16. So we've distributed. So after C, D, now we're ready for I. Identify. So we identify our terms. 80 is a constant, -8x is a variable term, and positive 16 is a constant. So we've identified our terms. Now we need to see, do I need to combine any like terms? You won't always have to do every single step, as like what we saw in the beginning of the problem. We didn't have to cross multiply in this problem. Do we need to combine like terms? Yes, we do. We have two constants we need to combine. Alright, we want to combine the 16 with the 80, because that 16 is currently with our variable and we want to get it away from the variable. So we write a -16 to make it a zero pair. But whatever we do to one side, we have to do to the other. Draw a big fat line and combine. So working from left to right, I have 80 and -16. Those are opposite signs, so I have to subtract. Borrow. 10 minus 6 is 4. 7 minus 1 is 6. So I get 64. And the bigger sign wins, and the bigger number was the 80. It's positive, so it stays positive 64. And I just bring down my -8x. So I've done combining my like terms. Now I need to isolate my variable from its coefficient. And if I look at my variable x, what are the numbers that are with it? I see a -8. So I divide both sides by, you say -8. Remember, the signs do not change when you're isolating your variable from the coefficient. That's only when you're combining like terms. So it's still divide by -8 and divide by -8. The -8's cancel out. So working from left to right, I have a -64 divided by 8, or divided by -8. So positive divided by a negative equals, I'm so sorry, equals a -64 divided by 8 is 8. And bring down the x. So -8 is equal to x, or x is equal to -8. I've run out of room on my screen, but maybe you have some more room on your paper. Let's go ahead and check our answer. I'm going to have to erase so that you can see my check. But don't you erase your work. Go ahead and just do it off to the side if you want to. Maybe in the margin of your paper. So I'm going to copy the original problem down, but wherever I see the variable, I replace it with the -8 that I think the answer is. So be careful on this. Don't just write -8 like this next to that 4, because then, well, you can imagine if it was a positive 8, it would look like the number 48. So you need to make sure when you replace a variable, put it inside parentheses, because sometimes it'll matter, and you'll see here that it does matter. Alright, now it might look like I got a little bit of a mess here, but for please excuse my dear Aunt Sally, says I need to do what's in those parentheses first. And so I've got 80 is equal to -2. I'm not going to distribute my -2. This is not an algebraic expression anymore. It's all numeric. When you have just numbers, that's when you use that please excuse my dear Aunt Sally. So I need to do what's inside parentheses, so I'm going to do that. And it looks like I have a 4 times a negative 8 minus an 8. So I have to do this multiplication first. 4 times negative 8 equals negative 32. And I'm just going to copy the rest of the problem down. I'm not going to rush it and try to do too much at once. That's where you make mistakes. Now I'm going to still do what's inside parentheses, but now I just have the one operation of negative 32 minus 8. Ooh. Everybody hates these. Why? It's a keep, change, change. We keep it, we change it, we change it. Subtraction. So a negative 32 and a negative 8, now we use our SOB. They're the same sign, so we have to add. Equals 40, and the bigger sign wins, so it's a negative 40. Almost done. 80 equals negative 2 times negative 4 is a positive 80. Yes, we did it. It checks out. We did the problem correctly. Okay, let's look at our second example. Again, if you see parentheses in a problem, bells and whistles need to go off in your head and say distributive property. Distribute, it's like use that double rainbow. Do we have any complex fractions? If we do, we have to do that before you even take care of that parentheses. Do we have that here? No, there's no complex fraction here. Alright, so now we're ready to distribute. I'm going to copy down the problem. 10 is equal to, and when I get to the parentheses, that's when I'm going to do my multiplication. So 3 times 2m is 6m, and 3 times positive 5 is positive 15. It is not the, you have to write that sign on there. I can't emphasize that enough, even if it's positive. And that positive 5 is not directly beside our parentheses, so it just copies down. It doesn't go away, it just copies down. So we're done distributing. Now we're ready to identify our terms. Now this problem is going to get really interesting. I'm glad that we're here, and that's why I find it so important to identify your terms. People get so weirded out with this. So I identified my terms. Did you do that correctly? You notice that negative 10 is a constant, positive 6m is a variable term, positive 15 is a constant, and positive 5 is also a constant. Now this looks slightly different from all of our problems we had before, but it's really not much different. The concept is still going to be the same. Our next step is to combine our like terms. We have 3 constants in this problem that we need to combine together so that we only have one constant. And just like before, we want to remove any of our constants away from our variable. So the negative 10 is going to stay put. But in this example here, we have 2 constants that we need to move. So we have the positive 15 that we need to move, and how do we move it? By making it a negative 15. But whatever we do to one side, we have to do to the other. So we made that 0 pair. Now we're not done yet because we have that other constant there, that positive 5, but we do the same thing. We make a 0 pair out of it because we don't want it to be there. But whatever we do to one side, we also have to do to the other. And I'm just going to write it down right underneath those other constants. I draw my big fat line and I'm ready to combine. So what do I have to combine here? I need to combine the negative 10 with the negative 15 and the negative 5. Those are all the same signs, so what I'm going to have to do? Same signs, add. You're just going to add all 3 of those numbers together. You can do that. 10 plus 15 plus 5. Now it doesn't matter what order you add them up together. Maybe I look at this and I say, oh, 5 and 15, that's 20. And 20 plus 10 is 30. So you can do that. It doesn't matter which order you add them up together in. But the bigger sign wins still, and they're all negative, so it has no choice but to be a negative. So you have a negative 30 is equal to, and the 6m just comes down. So we've combined all of our like terms. We just had more than what you normally do, and it's okay. You can have more than one number to combine. Now we're ready to isolate our variable. So let's see, do we need to do that here? We have a negative 30, that's a constant, and we have a 6m. Yeah, there's a number with our variable, so we do need to isolate our variable from, or our constant from the variable. We have a 6 that's beside our m. If it's beside it, we have to, yeah, I know you all know this by now, divide it. Beside it, divide it. So we divide both sides by 6. Make a little short line to show that you're dividing. The 6's cancel out, and you have negative 30 divided by positive 6. A negative divided by a positive is a negative. 30 divided by 6 is 5, is equal to our m. So negative 5 equals m, or m is equal to negative 5. Alright, let's check our work. Yes, I'm going to go through all 6 steps every single time. You can do it now. I need to erase it so that you can see me checking, but you can do yours on the margin. If you needed more time to copy things down or look at the problem, obviously you can rewind and pause and play back and forth as many times as you need to. So I don't mean to be going too fast, but I know you can just rewind or pause if I am going too fast. Alright, so we're ready to check. When we check, we just copy the original problem down. But wherever we see our variable, we're going to make a set of parentheses where we're going to plug in, copy everything down, the parentheses and everything. And notice I just made a, oops, I'm running off the screen there, so hopefully you can see that plus 5 on the end. It's still there. I made that set of parentheses as kind of like the hole or the space for me to plug in my solution that I think it is, the negative 5. So I have a negative 10 is equal to, and I'm ready to use the order of operations. I have to do what's inside parentheses first, so I copy down 3. I'm still going to write a parenthesis here because I have parentheses inside of parentheses and more than one operation. So I have 2 times negative 5 plus 5. Well, I have to do multiplication before I do addition. And again, I'm just going to do one step at a time. 2 times negative 5 equals negative 10 plus 5. So I just did that one operation, even though I know that negative 10 plus 5 is equal to negative 5. How did I know that? Oh, because they're opposite signs, I have to subtract. 10 minus 5 is 5, and the bigger sign wins, the negative 5. But if I do that, then I need to remember to copy down the whole rest of the problem with that. So negative 10 is equal to 3 times that negative 5 that's in that parentheses. Because whenever you have a number directly beside parentheses and only one number inside the parentheses, then those parentheses no longer mean like do what's inside of me first. Instead it turns into a multiplication. So if you ever have a number next to another number inside parentheses, it means to multiply. So that's what we need to do here. We need to multiply. I'm going to copy the rest of the problem down. Negative 10 is equal to 3 times negative 5. It's negative 15 plus 5. I had to do my multiplication before this addition here. So negative 10 is equal to, well, negative 15 plus 5 is opposite sign, so I have to subtract. 15 minus 5 is 10, but the bigger sign wins, negative 10. Hey, I did it. Negative 10 equals negative 10. Check. So when they ask you what's the solution to the equation, that's where you write m is equal to negative 5. But by plugging it back in, you just prove that that is the solution. Alright, last example, and then I'll give you time to work on your guided practice. Alright, do we have any complex fractions? No. So let's just distribute. This lesson's on distribution, so that's the only type I gave you right now. Have x plus, because it's a positive times a positive, so it stays positive. 7 times 6 is 42x. And yes, I have to write that positive there, 42, because it's no longer the first term in the expression. Or it never was. 7 times negative 6 equals negative 42, which equals to 44. Just copy down that equals 44. So I've finished distributing. Now I need to identify my terms. X is a variable term. 42x is a variable term. Negative 42 is a constant. And 44 is a constant. So here we're going to get into some new territory. We're ready to combine our like terms. And you haven't seen an equation like this yet where we have to also combine some variable terms. Now notice we have an x and a 42x. What's the coefficient of that x, by the way? Isn't that 1? Alright, so we need to combine all our circles together and all our squares together. And we don't want them on we want them to be on opposite sides of the equation. So we need to combine these two variable terms together. I do not, though, need to change any signs. Why? Look at the equation. Why don't I need to change any signs if I'm going to get ready to combine those two? Because they're both already on the left-hand side of the equation. They're already on the same side of the equation together. So I don't need to change any signs here. Unlike the negative 42 and the 44. The negative 42 is on the left and the 44 is on the right. So before I can combine them, I have to get them together on the same side. So that's where I have to do plus 42 plus 42. So that they're both on the same side of the equation together. So I'm ready to draw my big fat line and I need to combine. So when I combine, it means I need to combine my circles to my circles and my squares to my squares. You know, my variable terms together. So I have 1x plus 42x equals 43x. Don't just write 42x. Everybody forgets about that 1 there that you need to add to the 42. Is equal to, and I combine my constants together now. 44 plus 42 equals 86. Alright, so I've done combining my like terms. So yes, sometimes when you combine your like terms, you may have variables you even need to combine together. And now we're ready to isolate our variable. So we have our variable term and our constant. Good. We only have one circle and one square. We know we combined our like terms right if we have just one circle and one square. But now we have this 43 that's with our x, so that makes it a coefficient, and it's beside it, so we have to divide it. So we divide both sides by 43. 43's cancel out, and you get x is equal to 86 divided by 43 is 2, and it's a positive 2. Right? Are we ready to check it? If you need to push pause and finish copying or make a little note to yourself, you can. I'm going to write that x equals 2 off to the side so that I have some room to check my answer. Here, it might be easier for me to erase everything. We got x that was equal to 2, right? So let's plug it in. X is 2. Now, this equation has more than one variable. That's fine, but wherever we see that variable is where you need to replace it with 2. So we have 2 plus 7, parentheses 6. We have a variable that's right beside it. Because it's right beside it like that, I need to make sure I know that it means multiply, so I'm going to put inside parentheses 2. Sorry, trying not to yawn here. 6 equals 44. That's getting really sloppy. Let me rewrite that for you. That's a little bit better to see. Sorry about that. Alright, I have parentheses here. Oops, I was trying to change color so you can see it. I have this set of parentheses here. Now I see another set of parentheses right here, but I only see one number inside of it. So remember that that means to multiply. It doesn't mean do what's inside of me first. So I'm going to copy down the problem, but when I get to that set of parentheses, I need to do what's inside of it. So see how I just left it open? I have 6 times 2 is 12. 12 minus 6 is 6. So yeah, I did more than one step all at once, just as long as you know that you need to do your multiplication before your subtraction. Now I just have one number inside that parenthesis, so it no longer means do what's inside of me first, it means multiplication. So I see 2 plus 7 times 6 equals 44. Do not do this. Do not do this. That 2 plus 7, 9 like that. Why not? It looks like you should, but it shouldn't because, oops, because there's the multiplication. You have to multiply before you add. So you just copy down 2 plus 7 times 6 is 42 equals 44. 2 plus 42 is 44. Yay, 44 does equal 44. So we just proved that our solution is 2. Alright, it's your turn. Complete, check, and correct the 2.1 guided practice.